Welcome to Ko-Young here at Productronica. We're delighted to be joined by Harold Eppinger. Nice to see you again, Harold.
Hi, Trevor.
Okay, so let's start off with what's new here this week for Ko-Young.
Oh, first of all, the amount of visitors. It's amazing how busy the show is, even after the first day.
I know.
And the second aspect is that we are happy to show a few new things from Ko-Young. And I just can give you an example. We just released a new machine called Zenith UHS.
Yes.
And everybody knows the Zenith, but the Zenith, just to give you an example, this board was about 22 seconds. And the new generation is now at 12 seconds.
Wow. Wow, so how did you manage to achieve the increase in speed?
Definitely upgraded camera, but it's not just the camera and the megapixel. A lot of, you can buy cameras like hell.
Yeah.
But the problem is the methodology, we need really high-speed cameras to execute the frame rate. And that's the key. You need to have really good camera technology to utilize this speed.
And you probably need very strong software to be able to crunch that data behind it.
Of course, that's mandatory. It will not work out.
Right.
But this is exactly where it goes. On one hand, it goes in speed and throughput. But if you would like to get the same resolution or an even better resolution, you still have a high throughput. In the past was always you increase you improve the resolution, you cannibalize the speed. And with this camera technology, we can still go ahead with a good compromise for both.
Good, excellent. Okay. Now, a lot of companies in the inspection field talk about AI. I know that you've been working on it for a while, but you've got a special division actually, even down in San Diego, that works purely on that type of area. How are you seeing it being employed into the AOI business, and SPI business for Ko-Young?
I would say there's a big, let me say, you have to distinguish between two aspects of using AI. A lot of people are using AI to clean the database, to remove the noise in the database.
Right.
Ko-Young started with a R&D center to improve the performance of the machine, even to stabilize to a next level of quality, that the data in the database are really super rock solid.
Right.
And because of this, you can apply then engines to do automatic decisions processes. We are utilizing it, especially SPI. We have a real-time KPO, it's called. We are communicating between the printer and the SPI. We can do it for DOEs, but we also can use it really in real time to correct the parameters, to adapt the temperature of the paste and all these things. The goal is to keep the performance on the highest level and to reduce the bandwidth of the tolerance.
Right.
And the same is applied in the KPO for mounter. So we are analyzing the mounting process, and with our clear database and the engines behind, we can identify if it's the offsetted root caused by the nozzle, by the head, if there's a calibration necessary, is it the feeder who was replaced? And because of this, you can do this kind of, everybody's talking about predictive maintenance, but also you can secure that, again, the bandwidth of placement is very, very small and tight, instead of just allowing a big tolerance. And this is mandatory if you look to the next generation of PCBs, which are packaging and the semicon, which is our other topic.
Right. I mean, that's right. I mean, the tolerances in pick and place are according to IPC, are very wide. I mean, like 50% of the width of the component, which is an enormous amount, really. But I take that. Going back to your comment there on the printer, or the discussion between the SPI and the printer. You mentioned that you look at the temperature of the paste. Is that something
we see? No, I have to correct it. We look not at temperature. If the temperature of the paste is changing, the environment is changing, the result of the printing process, you can see the impact.
Of course.
We try to see if the stencil has changed, a different vendor has changed, we can see it and we can adapt the parameters that the outcome is great. So if you have a downtime on the line and you have the paste on the printer, there might be a change in the result. And this is what we try to continuously optimize, that the stability, you can really count on the print result at the end of the day.
Absolutely. No, I think the temperature and the humidity is a key parameter that has to be watched. Great. Well, I mean, it's fantastic to see that you're continuing your development on the AI side. I mean, coming into the operator level, do you see that at some point that you will be doing more by optimizing the operator level with AI?
Yeah, of course. Let me say, in the history of AOI, you have always the big topic of debugging. At the end of the day, it was time-consuming and very costly, and it was not very straightforward, of course. But going back to the measurement data and the real 3D data, it's not longer a discussion what kind of illumination and what kind of parameters you're using. It's more or less to interpret the result. And based on the historical data in our key smart factory, we can predict the tolerance of what is worse. As you mentioned, IPC is too much white. Somebody says, I'm producing according to IPC, I'm sorry for you. You can be better. So because we talk normally about 3 or 5 or maybe 7%. Yeah. And that's exactly the key why you underestimate your own performance by following a rule. But exactly this, you can look into history, what was the tolerance, the last 10,000 boards, last 5,000 boards, and you can apply exactly these tolerances into the machine. And that is also part of the auto-programming, auto-tuning, and in the auto-classification on the review station to reduce the workload and the responsibility on the operator level and to secure that the outcome is predictable, stable and high quality.
High quality, yeah. Excellent. Well, you're always innovating here, Harold, and it's great to see that Ko-Young is still coming out with yet faster machines and continue to develop things at an AI level.
Okay, thank you.
Thank you for joining us today.
Thank you.